Scientists don't use that word lightly, and they're using it now with increasing urgency across multiple systems at once. What makes this moment different from every previous climate warning is the sheer number of thresholds approaching simultaneously, feeding each other. 9 systems, each capable of reshaping civilization, are now moving toward their limits faster than our models ever predicted. Coral reefs are just one node in a much larger and more dangerous network. Scientists have identified 9 major climate systems, each capable of crossing a threshold that locks in irreversible change. They span every latitude: the frozen poles, the equatorial forests, the deep ocean currents that move heat around the entire planet. The Greenland ice sheet holds enough water to raise global sea levels by 7 meters if it fully collapses. The West Antarctic ice sheet holds even more. The Amazon rainforest, which generates its own rainfall, is already approaching the point where it begins converting to dry savanna. Atlantic Ocean circulation, the engine behind Europe's temperate climate, is measurably slowing. Permafrost across Siberia and northern Canada is thawing, releasing carbon that has been locked underground for tens of thousands of years. Each of these systems sits in a different corner of the planet, yet none of them fails alone. A collapse in one raises the pressure on all the others, tightening a web that now spans the entire Earth. The Arctic is warming nearly 4 times faster than the rest of the planet, and that gap is widening every decade. For thousands of years, white sea ice acted as Earth's mirror, bouncing roughly 80% of incoming sunlight back into space. When that ice disappears, the dark ocean beneath it absorbs that same energy instead of reflecting it away. More heat enters the water, which melts more ice, which exposes more ocean, which absorbs still more heat. Scientists call this the ice albedo feedback loop, and it doesn't need our help to keep running once it starts. Summer Arctic sea ice has already shrunk by more than 40% since satellite records began in 1979. The system isn't approaching a threshold, it is dismantling the mechanism that held the threshold in place. What happens in the Arctic doesn't stay there. Warmer polar air disrupts the jet stream, destabilizing weather patterns across the entire northern hemisphere. Droughts deepen in one region while floods intensify in another, all traced back to a feedback loop accelerating above the Arctic Circle. Greenland sits at the center of what comes next, and its story is far harder to walk back. Beneath Greenland's surface, meltwater lakes are quietly drilling through 2 miles of ancient ice. Each summer, that water carves new channels downward, lubricating the base and accelerating the sheet's slow slide toward the sea. Scientists have identified a threshold somewhere between 1 and 2 degrees of warming where this process becomes self-sustaining. Cross that line, and the ice sheet doesn't need us anymore. It melts on its own terms, on its own timeline. The consequence isn't measured in inches of sea level rise. It's measured in 7 meters. That's enough water to permanently redraw every coastline on the planet. Miami, Mumbai, Shanghai, Amsterdam. Cities built over centuries would surrender to the ocean within decades. 300 million people currently live on land that Greenland's collapse would eventually claim. And the most alarming finding from recent research is that we may already be closer to that threshold than our emissions target. Greenland isn't a distant warning. It's a deadline written in ice. And the ice is already answering. The Amazon rainforest generates roughly half its own rainfall through a cycle of evaporation and release. Cut enough trees and that cycle breaks, not gradually, but all at once, like a switch being thrown. Scientists call this an ecosystem regime shift, and the Amazon is already showing early warning signs of the transition. Deforestation has claimed nearly 20% of the forest in just 5 decades, and drought stress is compressing what remains. The trees that survive are releasing less moisture, weakening the very rainfall system that keeps them alive. At a certain threshold, somewhere between 25 and 40% total forest loss, the system may simply stop sustaining itself. What follows isn't a slow fade, but a rapid conversion. Dense rainforest collapsing into dry savanna within decades. That shift would release hundreds of billions of tons of stored carbon directly into the atmosphere. It would also sever the aerial river that carries rainfall deep into South America, triggering agricultural collapse across an entire continent. The Amazon isn't just a forest, it's a climate engine, and it's running out of fuel. Beneath the frozen ground of Siberia and Alaska, something ancient is beginning to wake up. For thousands of years, permafrost locked away dead organic matter, holding it frozen and inert beneath the surface. But as global temperatures climb, that frozen ground is thawing, and the consequences reach far beyond the Arctic. Inside that thawing soil, microbes are consuming ancient plant material and exhaling methane, a greenhouse gas 80 times more potent than carbon dioxide over 20 years. Every fraction of a degree of warming accelerates the thaw, which releases more methane, which drives even more warming in return. Scientists call this a feedback loop, and what makes it terrifying is that humans have no lever to stop it once it begins. The Arctic holds an estimated 1.5 trillion tons of frozen carbon, more than double what the atmosphere currently contains. If even a fraction of that escapes, it could overwhelm every emissions cut humanity manages to achieve. This is the tipping point that doesn't announce itself. It simply crosses, quietly, beneath your feet. And while the Arctic silently exhales, the ocean currents that regulate the entire planet's climate are already showing signs of collapse. Beneath the Atlantic surface, a conveyor belt of water has been moving heat around the planet for millennia. It's called AMOC, the Atlantic Meridional Overturning Circulation, and it's slowing down. The mechanism is deceptively simple. Melting ice sheets pour fresh water into the North Atlantic, diluting the salt concentration that makes cold water dense enough to sink. When that sinking stops, the entire circulation weakens, and the engine that moderates Europe's climate begins to stall. Scientists measuring ocean density gradients have found that AMOC is now at its weakest point in over 1,000 years. A full collapse wouldn't just freeze northern Europe, it would shift monsoon patterns across Africa, Asia, and South America simultaneously. Hundreds of millions of people depend on those rains for every harvest they grow. What makes AMOC's vulnerability so alarming is that it doesn't fail in isolation. Its collapse puts pressure on every other system already straining at its limits. The tipping points aren't standing in a line waiting their turn. They're connected, and when one falls, it pulls on the others. None of these tipping points exist in isolation. And that's what makes the science genuinely alarming to researchers. When Greenland's ice melts, it slows the Atlantic circulation, which shifts rainfall patterns across 3 continents simultaneously. Disrupted rainfall dries the Amazon, and a drying Amazon releases carbon that accelerates the warming, driving all of it. Each threshold crossed doesn't just add to the problem, it multiplies the pressure on every system still holding. Scientists call this a cascade, and no climate model has fully captured how fast one could unfold. The honest answer is that we don't know which threshold falls first, or exactly when the chain reaction begins. What the research does tell us is that these risks are not distant or theoretical. They are measurable and they are growing. Understanding that is not a reason for paralysis, it's a reason for clarity. The decisions made in the next 2 decades will determine which version of this century humanity actually lives through.